Hello everyone, my name is Jesús Armijo. I'm going to present my paper entitled EADAS, Assisted Adaptation Scheme for HTTP Adaptive Streaming. First, I will do a brief introduction and then I will talk about some characteristics of EADAS, like the algorithm, segment prefetching management, clustering by subscription, and then I will finalize with the results and questions and answers. So client-based algorithm has limited information available to perform its adaptation decision. And usually edge-based EBR algorithms are based on optimization model with time slot where they collect all the different segment requests from the users. But these requests usually are not synchronized in real world and they might have different segment duration, like 2 seconds, 10 seconds. So in this work, we propose EADAS. That is an edge-based algorithm that supports the client-based EBR algorithm, not substituted, improving its adaptation decision. So EADAS provides awareness of other user requests, segment prefetching support, and different level of subscription. EADAS operates on the fly manner with minimal latency added, and it is lightweight in contrast with other state-of-the-art, more heavy approaches. As we can see in the image at the right side, EADAS is deployed at the edge computing node, and it's where it has computing power and storage. And it intercepts the segment requests from the user and may modify it. So the EADAS algorithm is executed for segment request and for each user. It focuses on improve the QE and the fairness among the users. We introduce an alpha value in our algorithm that can taste and the QE or fairness. It's management. They do the match of this stuff according to our preference. So lower alpha values in our algorithm means that we prioritize fairness. Higher alpha values, we prioritize the QA. We have the full algorithm in the paper in case you are interested, but one important line is that we can show that this trade-off is this way, that the higher alpha value will give more importance to the QA, to the quality store, and the opposite with fairness. Here we show some simulation that for no EADAS or different values of EADAS, and we can see that EADAS improve a lot the QE and the fairness, but depending on the alpha value, as I said, it improves more the QE or the fairness. For example, for a lower alpha values, that is this one, we can see that the fairness is high and the QE is a good increasement, but still it can increase more if we put higher alpha values. The EADAS supports segment prefetching. In this paper, we study 3 different segment prefetching policies, analyzing the costs and benefits. We use last segment quality, we call it last segment quality, that we prefetch the last segment quality to the edge, so it's available to the user with low latency. And last segment quality plus, this is we prefetch the same quality, one above or one below, and all segment qualities, we prefetch every segment quality. We test SARA EBR algorithm without EADAS, because what we wanted to show is in the results that the best QE is obtained without segment prefetching. This is because it's hybrid and throughput-based EBR algorithm. If you include prefetching, you will have some radio throughput miscalculation, so that leads to a poor QE. EADAS solved this problem. It was designed to support segment prefetching and leverage the good benefits that they may have. We can see also that the prefetching hit rate for LSQ plus is a solid 76%, and the cost that is sent data through the network is like 10 times more than no segment prefetching. So we used LSQ plus in our experiment later on. The clustering per subscription characteristic of EADAS is that users that pay more, like premium users, may want to have a better performance. So we prioritize this premium user, the EADAS algorithm group users. So we group into the basic user and premium users, and you can see in the results is that we perform the evaluation for SARA and SARA EADAS, And we can see that EADAS increase both QE for basic user and premium user. But for premium user, it increased more. That is our goal with our algorithm. We can see that in here with premium user is at 26% the QE, and for the basic user is at 20%. This a solid number, but a little bit less. That was the main point. Also, EADAS increased the fairness in both, so it's close. Finally, the EADAS results we test with 3 different time-based ABR algorithms with 3 different logic: throughput-based, buffer-based, and hybrid-based. We test the experiment setup is in the paper in case you are curious about that, and we test using real 4J traces. So we can see here the BBA plus EADAS, throughput-based, and EADAS, and SARA EADAS. We can see that in these 3 ABR client-based ABR algorithm, we increase the QE significantly. We also increase the fairness. We complete this, but for example, for BBA, that the mean rate is usually a little bit lower. We increase this mean EADAS increase this mean rate by requesting more aggressively, more higher qualities. And for example, for throughput-based, that is really aggressive. And for these real 4G radio traces, that throughput has some drops, some sudden drops. We can see that it decreased EADAS decrease a lot the number of stalls in throughput-based and SARA ABR. So we can see that EADAS improved the Q and improve the main fairness index for all these different ABR algorithms. So thank you so much. If you have any question, I'm happy to answer.